All right, folks. Plan for today, same as last two classes. So we'll take 30 minutes or so, talk about some test 3 stuff or other questions you guys might have had, homework or whatnot. Then we'll go and do a little bit on 3-9 and call it a day. Sound good? All right. Do you guys have any specific questions before we dive in here? Something you saw in the homework, or if you're looking through the multiple choices or the 3 responses, or any of that jazz that you wanted to ask about, now would be a great time to do that. If not, I'll just fill, Peyton.
Could you maybe do one of the effort cues, or like the ones where it gives you like a little table of values and that?
Scroll down. So we did this one the other day, right? So you want to do this one then? Is that what you're asking for?
Yeah.
Okay. All right. It says a bowl of soup, or as a bowl of soup cools. Oh boy. Oh, he's not here. As a bowl of soup cools, the temperature of the soup is given by the twice differentiable function h for 0 to 12, where h of t is measured in degrees Celsius and t is measured in minutes. Values of h of t at selected values of time t are shown in the table above. Use the data in the table to approximate the derivative of h at 5. Show the computations that lead to your answer. Using correct units, explain the meaning of h prime of 5 in the context of the problem. So if I'm going to approximate h prime of 5, if you're asked to approximate the value of a derivative, you're likely just being asked to use slope, right? Rate of change is fine, yep. So if I'm going to calculate the slope, which points from the table would give me the most accurate estimate for the derivative of h at 5? Using the middle 2 points, yeah, where the t-values are 3 and 8, those most closely bound 5. Best we can do with the table that we're given. So what's that going to be? Negative 13 over 5 for negative 2.6. Does that all look okay to you guys? Okay. Asked for a unit on this. What unit should we give this? Close. Remember, slope is change in y over change in x. So degrees Celsius over minutes. And then it says, explain the meaning of h prime of 5 in the context of the problem. So we would start like at time t equals 5 minutes, or you could say after 5 minutes. That would be okay too. What would we say then? Okay. The temperature, and let's be specific, of the soup is, and I'm going to say, use a math word like decreasing. And since it's a derivative, I'm also going to try to use the word rate. Notice I didn't write negative 2.6 here. Why didn't I write negative? Because I said decreasing. Perfect. Yes, 100%. Again, you could say changing at a rate of negative 2.6. That would be fine, right? Means the same thing. And again, this is just kind of like whenever they ask, you know, like, what does this mean in the context of the problem? They're looking for you to, you know, like, relate it back to the specific story about it, right? So far, so good? Okay. So in B, it says, is there a time t from 0 to 12 at which the temperature of the soup is 60 degrees Celsius? Justify your answer. So it's asking, is there a y value exists on this interval of x, right? That should scream to you intermediate value. Perfect, yes. So to do the intermediate value theorem, we need two things at the beginning. The first thing we need to show is continuity. How do we know h is continuous? Good. So h is continuous because it's twice differentiable. Okay? And then the second piece that we need is we need two y values that sandwich, in this case, 60 degrees. What would those two y values be? 58 and 67, right? So I'm going to say since h of 12 is equal to 58, which is less than 60, which is less than 67, which is equal to h of 8, right? Yep. The IVT states there exists a C on the interval from 8 to 12 such that h of C is equal to 60. So again, the IVT requires two things at the start. You need continuity, and then you need two y values that sandwich the y value of interest. And then the IVT just states there's going to be a y value that takes on the desired value inside the corresponding x's, right? So far, so good? And you guys remember the verbiage on the IVT here? We practiced that a lot. I think that we should hopefully still remember that. If not, brush up on it quickly. You know, it should be review, which hopefully means it'll go pretty quick if you didn't remember. It says the temperature of the soup is also modeled by the twice differentiable function C. For 0 to 12, where C of t is measured in degrees Celsius and time is measured in minutes, it is known that C of 3 equals 80, and the derivative of C, given by C prime of t, is equal to negative 3.6 e to the negative 0.05 t. Write an equation for the line tangent to the graph of C at t equals 3, and use that to approximate C of 5. So if I want to write the equation for a line, I need two things, right? Typically they would be point and a slope, right? The point is given to me. What is the point? 380. Like that's a point on C. And the slope is, that we want, is going to be no, goodness gracious, Mr. Boyle. C prime of 3. And again, that slope needs to match, or the x-coordinate for my slope needs to match the x-coordinate for my point, right? Because if I'm drawing a tangent line, it's got to go through the point, so the slope's got to be the one at the point. So far, so good? So to calculate C prime of 3, I could either, it's calculator active, I could do this on my calculator to find the derivative of C at 3. Or if it's not, this is perfectly inside of our capabilities of doing by hand. So if we were doing this by hand, the derivative of C of t is going to be negative 3.6 e to the negative 0.05 t. Oops. 0.05 times negative 0.05, right? Just as my chain rule, little chain rule there. See the bitty guy? So C prime of 3 then is going to be positive 0.18, I think. Negative 0.5 times 3. Does that look right? Negative 0.05 times negative 0.36. Kate's shaking her head yes. She's got her calculator out, so I definitely trust her on that. It's close?
I got 0.2.
0.2.
Like 0.2.
Because 0.5 times 3.6 should be 1.8, right? If 0.2 is correct, Anthony? Because I'm thinking just half of 3.6 is 1.8, and then I divide it by 10 also. Am I not right on that? You got 0.18? Oh no. Is your calculator in like engineering mode or something where it's rounding to sig figs or something? 0.18. Yeah, okay. I got 0.18 also. Look at your mode. You definitely want to square that away before we get too far. Okay. I might as well just grind that through and get a decimal out of that so we can use that. And so then we could say that C of t is approximately slope times x minus 3 plus 80. Everybody okay? That's just this point slope formula with the y added to the other side, the y1. And then so C of 5 is that. So I get about 80.31 degrees. Yes. I don't think so, because it doesn't specify correct units. I think it's pretty standard. Is that okay, everybody, with what we did there? Okay. And then on D, it asks based on the model given on part C, at what rate in degrees Celsius per minute is the rate of change of the temperature of soup changing at T equals 3 minutes? What is it asking for in this? The second derivative, excellent. How did you, what in here cued you that this was a second derivative? Okay, rate of change, right? Or, what would have been the other clue? There's a second clue in here that would have told you second derivative is what you're looking for. Yeah. Yeah, per minute. As soon as you see two pers, probably talking about a second derivative, unless the first y variable is given as a rate already, which could happen. So this is just C double prime of 3. So C double prime of t is going to be 0.18 e to the negative 0.005 t times negative 0.05. I think it's that guy.
Just have a question on parts.
Yeah, go ahead.
So the instructions in part C, like on the do it say that negative 3.6 GC negative 1.5 is a derivative of t.
Oh my gosh! It sure did, didn't it? Good catch. So we did a bunch of stuff wrong there, right? Okay. Yeah. Next time you see me doing stuff wrong, Lucas, you just like, don't let me keep going. Okay. So M is just C prime of 3, which is negative 3.6 e to the negative 0.05. That guy. No derivative necessary. Woo! Thanks, dude. Thought the answer seemed a little bit funny, but I'm just like, okay. Just was gonna go with it. I'm like, I would have thought the temperature should have decreased. That's better. My apologies. Yikes! Peyton, does that feel okay?
Yeah.
Now notice that problem is basically the same as the previous one, right? Just with like slightly different situation, different numbers. What do you think the odds are you see something on the test that's awful similar? Probably decent odds, right? So I would definitely make sure I've reviewed that problem. I can kind of do that. If I give you a similar situation, it should feel pretty comfortable. Sorry about the mistake. Should we do the other FRQ there at the end to finish us out? I think that's a implicit differentiation problem. Okay. All right. So it says, consider the curve defined by the implicit formula, negative 8x squared plus 5xy plus 3y, or plus y cubed equals a negative 149. Find the derivative. Okay, what do I need to do to find the derivative? So what am I going to get? Take the derivative of both sides, right? Excellent. Any questions on how Anthony got there? Okay. Does anyone have any questions on the algebra that you use to get the dy dx by each one? No, because we differentiated the x on that part, so no differential term gets generated there. Is that, you see it?
Yeah.
Okay. Does anybody have questions about the algebra we use to get the dy dx by itself? If not, I'm just going to like shortcut straight to the answer. Are we good? So add 16x over, subtract 5y over, factor off the dy dx and divide by 5x plus 3y squared. Part B says write an equation for the line tangent to the curve at the point 4, negative 1. So we have the point, right? How we can get the slope? Plug in 4 and negative 1 into our derivative, right? Four times 16 is 64, plus 5 is 69. 5 times 4 is 20. Negative 1 squared is 1, plus 3 is 23. So I get 3 for my slope. That's nice. So everything I need. And again, you could simplify that more if you want to, or just leave it the way it is. No biggie. So far, so good. Everybody like what we got into? Okay. C says there is a number k so that the point 4.2k is on the curve. Using the tangent line found in part B, approximate the value of k. What do I have to do here? Just plug in 4.2 for x, right? So k plus 1 equals 3 times 4.2 minus 4. So k is going to equal, that's 0.2 times 3 is 0.6, minus 1 is negative 0.4. Easy enough, right? Part D, it says, write an equation that can be solved to find the actual value of k so that the point 4.2 comma k is on the curve. How would I do that? It's on the curve. What is the equation for the curve? It's the original, right? When we talk about the curve, that's the curve we're talking about. So to solve for k, what am I going to do? Plug 4.2 in for x and k in for y, right? That ought to do it. Alternatively, what else could you do? You know, at 4 point, we have the derivative, right? We could plug 4 point, oh no, we don't want to do that. That's the best way of doing it. So we have 8 times 4.2x squared plus 5 times 4.2 times k plus k cubed equals negative 149. Now I'm looking at this equation that I have to solve for k, and I do not like what I see. Why don't I like what I see here? What type of polynomial is it? It's a cubic. How many terms does the polynomial have? 3, right? Is there any by hand method that you can think of to solve a 3-term cubic where one of the terms is a constant? Because in all my mathing, I do not know of one. What am I left with if I know no by hand methods? Well, can't do a quadratic formula because it's cubic, right? What else could I do? You're not going to be able to factor this using any method that I can think of. That's not going to help us. Simpler than that. Yeah, this is going to have to be a calculator problem. If you are unsure of the algebraic method to solve a problem, what is the calculator method that you should use? Graphing, right? So there are 2 ways you could approach the graphing. You could graph left-hand side, right-hand side, look for the intersection, or you can move everything onto one side and then look for the x-intercepts. That's what I'm going to do because I hate this negative 149. That's going to make for like a pretty crazy looking window. So I'm going to add that over. And we'll get this into our calculator here in a minute and find the solution. It's probably going to be a decimal. Looking at the equation, I would not be surprised at that. Oh, goodness. All right. So let's do that so I can kind of see what I had there. Come down a little. Come back up. There we go. So I'm going to have 149 minus 8 times 4.2 squared plus 5 times 4.2 and then x plus x cubed. Notice I didn't bother simplifying anything. Like, you could type those numbers in your calculator and get like a normal number out of it, but like it's all going in the calculator anyways. Like, I'm just not going to waste my time with that. Everybody's okay? So now I'm looking for x-intercepts because I added the 149 over. So I don't have any intuition as to like what this value for k should be, other than that I would hope, you know, -1 was where it was at 4. I'd expect it not to be too crazy. So I would expect the standard window here to be fine of just graphing from -1 to 1. So I'm just going to do a zoom standard, or -10 to 10. So I'm just going to do a zoom standard. And that works, right? There's my x-intercept. It is relatively close to -1. So the 0 command, left bound, right bound, guess. So -0.373. If this was a no calculator question, I have no idea how they'd expect you to solve for part B. I can only guess that this is a calculator question, because it is completely infeasible otherwise. And that's about 30 minutes in, guys. You guys, how's the test 3 prep going? It's been okay? All right. Let's do a little bit more 3.9 and yes, sir. They didn't bring your pass? Yeah, that's fine. Sure. We're gonna do one more of these examples, and then I'm just gonna let you guys work on that packet of related rates questions for the remainder of class. Sound good? Okay. It says car A is traveling west at 50 miles per hour, and car B is traveling north at 60 miles per hour. Both are heading for the intersection of the two roads. At what rate are the cars approaching each other when car A is 0.3 mile and car B is 0.4 mile from the intersection? Does everybody get what's going on in the picture? See you later. Forget what's going on in the problem? And we have like two cars that are coming together like this, right, at an intersection. So let's draw ourselves a picture. So car A is traveling west. And car B is traveling north. They're both heading towards the same intersection, right? Everybody feel good about what we've drawn there? All right. So when I look at this, I'm going to call those lengths X and Y. And who is surprised at what the third thing I'm going to be drawing in is? Hypotenuse, yes. I'm going to call that guy Z. And like any good civil engineer, I'm going to assume that my roads are intersecting at a right angle. Sorry, Woodward Avenue. Because everything's diagonal road, everything comes in at not a right angle. Everybody feel good here? Okay. Let's identify what are variables for us with respect to time. So X, Y, and Z, are these changing at each instant? Yeah, right? Like Y is getting shorter, X is getting shorter, Z is getting shorter. So these are all variables with respect to time. Hi.
Hey, for Kimberl Alice, we're singing for 9th hour.
Okay. She's coming. Yep. Everybody happy here? Right? So if we look now, we have two quantities, right? Or that are given right away. Car A is traveling west at 50 miles per hour. What are we going to call that quantity? What kind of quantity is it? Speed, which is a type of velocity, which is a type of, more generally than that, see Alice? It's a type of rate. How do we name rates? With a derivative. So I'm going to name car A traveling west at 50 miles per hour. I'm going to name it as dx dt. Is everybody okay with that? What else can I say about that? It's negative? Is that what you said, Anthony? That's correct. It is negative. But it doesn't say decreasing or anything here. How did you know that was going to be negative? I wouldn't think about it that way per se. Think about the length of x. That's getting shorter, right? As it's moving west, that length of x is getting shorter. So the derivative should be negative. Because if it was on the other side, if we drew it the other way and they're like traveling apart from one another, even though it was heading west, it would need to be a positive derivative. Because then the x is getting longer, right? If instead this guy was going this way and this one was going this way, instead of approaching an intersection, they're leaving an intersection. Even though one is going left and the other is going down, their derivatives are both going to be positive because the distances, x and y, are increasing. Rough, right? Yeah, not what you expected. But that's why we're doing this, right? Is to talk about how to handle this stuff. Then it says car B is traveling north at 60 miles per hour. dy dt is also going to be negative. Again, because that length for y is decreasing. Even though it's heading north, heading in the positive direction on the y-axis. That doesn't matter to us. It matters what's happening to the length of y in our picture, right? Because y is the distance from the car to the intersection. Okay. Both are heading for the intersection of the two roads. At what rate are the cars approaching each other when car A is 0.3 mile and car B is 0.4 mile from the intersection? What rate are the cars approaching each other? What are we going to call that? What? It's going to be dz dt because it's what rate. Remember, z is the distance between the two cars. And we're not interested in just dz dt in general, but specifically when x is 0.3 and y is 0.4. Everybody feel good with our setup here? Okay. Notice that we've spent a good chunk of time just kind of talking through how do we name things, what are we calling stuff, drawing our picture, making sure the signs are right on our rates. This is the hardest part, the part that we just accomplished. Okay. What equation are we going to use to relate the variables together? Pythagorean theorem is the obvious choice, I would hope. You know, you're given a triangle, you know nothing about the area, you know nothing about the angles. It's a right triangle, the only thing left would be the Pythagorean theorem. Now that we've done that, we'll differentiate with respect to time. What is the derivative of x squared be? 2x dx dt. And the derivative of y squared? And the derivative of z squared? Good. Is everybody okay? Let's start filling things in. Uh-oh. I don't have, what's my value for z? Good. So this, again, when we look at the beginning here, we have two rates. We're asking for the third. There's only three rates in our derivative, so we should be good. There shouldn't be a need to do a clearing, change in variable or anything like that to take care of things. And Anthony's 100% right that this z we can find because at this point we know x is 0.3 and y is 0.2. So z has to abide by the Pythagorean theorem. So we're there. And we're done, right? Just grind some numbers. So the takeaway on this one, the added wrinkle that this was the example for, is the importance of making sure you're thinking about whether your rates need to be positive or negative based on your picture, not necessarily the wording. Sometimes they'll be nice, and they'll say decreasing or increasing, and it'll be really clear. whether your rate should be positive or negative. Other times, they're going to count on you being able to sort that out from looking at the picture as to what's happening. This is an example of that situation. Okay? I'm going to stop here. You guys have your packet of related rates problems that we passed out last time. Just take that out and kind of pick up wherever you left off. Try to get a little bit done today. If you have questions about stuff, feel free to come up and ask. Hopefully you're a couple of questions in at this point, but if you're just getting started still, that's okay. Let's make some progress today if that's the case. Sound good?